Hello there, and welcome to Deep Sleep Science. Tonight, we wander into one of the most extraordinary mysteries your mind carries within it. The invisible worlds it builds each night while you rest. Every evening, as consciousness gently dims, your brain begins composing experiences so vivid they can quicken your pulse, bring tears to your eyes, or fill you with a joy you cannot name upon waking. Wherever you are right now, perhaps lying beneath the familiar weight of your blanket, or settling into the soft darkness of your room after a long day, know that nothing is expected of you tonight. You do not need to remember any detail we explore together. You do not need to follow every word or hold on to any single thought. If sleep arrives before we reach the end, that is perhaps the most beautiful outcome this evening could offer. Tonight, we drift through 100 quiet truths about why your brain dreams the way it does. We will explore the strange chemistry that paints your nighttime visions, the ancient patterns that connect every dreaming mind across cultures and centuries, the memories that reshape themselves while you rest, and the remarkable neuroscience behind experiences that feel absolutely real, yet dissolve like morning mist. Dreaming, it turns out, is not a random accident of sleep, but something your brain approaches with extraordinary care and purpose. This thoughtful journey through the dreaming mind builds bridges between curious souls seeking peaceful rest. A gentle like or subscribe helps another sleepy soul discover this quiet sanctuary. One resting thought, one peaceful night at a time. Your presence here inspires ours. For now, let everything beyond this moment grow distant and still. Allow your jaw to soften. Let your shoulders release whatever tension they have been holding. Imagine your breathing settling into whatever rhythm feels most natural. Each exhale carrying something you no longer need. Picture yourself drifting slowly in a warm, dark current that asks nothing of you except to be carried forward. Close your eyes whenever you feel ready. Take one slow breath in, hold it softly, and let everything dissolve as we begin. Your sleeping brain operates within a chemical environment that exists at no other point in your waking day. During dreaming, acetylcholine, a molecule linked to vivid sensory perception, surges to concentrations matching full alertness. At the same time, norepinephrine and serotonin, the neurotransmitters responsible for logical reasoning and emotional steadiness, retreat to their lowest levels. Research from 2025 mapped this unique neurochemical landscape in unprecedented detail, revealing that each REM period creates a subtly different chemical environment than the last. This unusual mixture may explain why dreams feel simultaneously hyper-real and impossible, your mind generating sensations as convincing as daylight, while the systems that would normally question them have quietly stepped aside. Like a theater where the spotlight blazes brighter than ever while the critic in the audience has drifted into the deepest sleep. During lighter stages of rest, your brain produces brief electrical pulses called sleep spindles, rapid oscillations, lasting barely 1 to 2 seconds each. These spindles serve as coordination signals, helping distant brain regions synchronize their activities before deeper sleep arrives. Research from 2025 revealed that people with stronger spindle activity tend to report more structured and memorable dreams during subsequent REM periods. Some scientists believe these electrical bursts prepare the neural stage for the elaborate experiences that follow, organizing conditions that allow vivid dreaming to unfold with such convincing detail. These tiny electrical ripples spreading through your sleeping brain are like musicians quietly tuning their instruments in darkness. Preparing for a performance no audience will ever consciously witness. A compelling theory emerging from 2025 research proposes that dreams function as your brain's way of testing its internal models of reality. During waking hours, your mind constantly predicts what will happen next, updating those models whenever surprises occur. Dreams may represent the brain running simulations to refine these predictions without any external input, generating scenarios and observing how internal expectations respond. By rehearsing countless possibilities each night, your sleeping mind strengthens its ability to anticipate the waking world more accurately. Your dreaming brain practices navigating realities that may never exist, like a chess player who studies the board long after the opponent has gone home, imagining moves that sharpen strategy, regardless of whether they ever appear in an actual game. Whatever occupies your mind in the hours before sleep often finds its way into the worlds your brain constructs at night. People who spend their evenings immersed in video games frequently dream of those digital landscapes. Those who study intensely may find equations and diagrams drifting through their sleeping thoughts. This influence extends beyond activities into emotional states themselves. Falling asleep while feeling peaceful tends to color dreams with gentler tones, while drifting off during anxiety may darken them considerably. Research from 2024 confirmed these patterns across thousands of dream reports, showing that pre-sleep mental states predict dream emotional content with surprising reliability. The threshold between waking and sleeping remains permeable, carrying the atmosphere of your final conscious hours into territories you will explore without awareness. Curiously, the experiences of today rarely appear in tonight's dreams. Researchers have identified a phenomenon called the dream lag effect, in which events tend to surface in dreams approximately 5 to 7 days after they occur rather than immediately. Studies published in 2025 confirmed this delay across multiple cultures, age groups, and types of experience. The gap may represent the time needed for memories to migrate from temporary storage in the hippocampus to broader networks across the cortex, a journey that requires processing before new material can be integrated. Your dreams draw from a library that needs time to catalog new arrivals, like letters that must travel through a sorting office before reaching their intended destination in a distant wing of the building. One influential theory suggests that dreams evolved primarily to help you rehearse responses to danger. The threat simulation theory proposes that your sleeping brain creates scenarios involving predators, falls, social rejection, and other challenges, allowing you to practice survival strategies without actual risk. This would explain why negative emotions appear in dreams more frequently than positive ones across nearly every study conducted. Evolution may have favored minds that spent their sleeping hours preparing for trouble rather than simply resting in pleasant images. Your nightmares might be ancient training simulations, programs inherited from ancestors for whom a sleeping brain that rehearsed escape could mean the difference between surviving another morning or becoming part of someone else's story. The unsettling dreams that occasionally wake you with a racing heart may serve protective purposes your conscious mind does not fully appreciate. In threatening dream scenarios, your brain activates the same fear circuits used during genuine encounters, practicing emotional and physical responses within a completely safe environment. Research from 2024 found that people who experience moderate nightmare frequency show faster real-world threat detection and more flexible fear responses than those who rarely dream unpleasantly. The sleeping mind does not generate fear to torment you, but to prepare you for moments you may never face. Like a fire drill conducted in complete darkness, the alarm feels genuine and the urgency compels movement. Yet you remain protected throughout, gathering readiness that may one day prove essential. The twilight moments between full wakefulness and sleep, a state scientists call hypnagogia, produce some of the most unusual experiences the mind can generate. As you drift toward unconsciousness, spontaneous images may bloom behind your closed eyelids. Vivid and unbidden, sounds emerge from silence. Sometimes voices calling your name, sometimes fragments of music with no recognizable source. Your body may feel as though it is expanding beyond its boundaries or shrinking to a point. This borderland between two states of awareness shares qualities with both dreaming and waking consciousness, creating a brief window where the rules governing each dissolve into something fluid and unfamiliar. A shoreline where two oceans meet and neither claims dominion. Throughout the night, your brain experiences brief moments of near wakefulness called micro-arousals, lasting only seconds before consciousness sinks back into deeper sleep. Research from 2025 discovered that these fleeting interruptions serve an important surveillance purpose, allowing your brain to scan the environment for potential threats before permitting sleep to deepen again. Most micro-arousals leave no memory trace whatsoever, but they may subtly influence dream content, creating moments where external reality briefly touches the ongoing dream narrative. These tiny surfacings are like a diver who rises momentarily for a single breath before descending again into the deep. Each brief return to the surface confirming that the world above remains safe and undisturbed. The people who populate your dreams often carry uncertain or shifting identities that would seem impossible in waking life. You might recognize someone as your closest friend even though their appearance bears no resemblance whatsoever to that person. Characters may transform from one individual to another mid-scene, without any sense of strangeness or surprise. During waking perception, multiple brain systems collaborate to identify someone through face recognition, voice analysis, and contextual knowledge. In dreams, these systems may provide conflicting information that the dreaming mind simply accepts without question. Identity in dreams becomes a feeling rather than a visual fact, a knowing that lives in some deeper place than what the eyes report, as though recognition itself has roots that extend beneath appearance. This fluidity of identity extends to the dreamer as well. In most dreams, you experience events from your usual perspective, your familiar sense of self navigating unfamiliar territory. Yet some dreams involve inhabiting someone else entirely, observing the world through a stranger's eyes, thinking a stranger's thoughts without questioning the arrangement. Other dreams dissolve the self altogether, leaving only witnessing without any clear observer attached. These extraordinary variations suggest that your sense of personal identity during sleep is far more flexible than waking consciousness ever allows. The boundaries of selfhood soften in dreams, becoming permeable and curious, like watercolors bleeding gently into one another across paper that has been left out in gentle rain. Some people awaken to find their minds fully alert while their bodies remain completely immobilized, a condition called sleep paralysis. This occurs when the muscle suppression that normally accompanies REM sleep persists into waking consciousness, leaving awareness stranded in a body that cannot respond to any command. The experience frequently carries a profound sense of unseen presence, as though something invisible occupies the room. This sensation likely results from the amygdala activating during the incomplete transition, interpreting the body's helplessness as evidence of danger. Understanding the neurological mechanism behind this experience can significantly reduce its frightening quality. Sleep paralysis is simply a timing mismatch, the mind crossing a threshold that the body has not yet reached, like arriving at a door that requires only a moment longer to unlock. The sensation of floating, falling, or spinning during dreams originates partly from your vestibular system, the balance apparatus located deep within your inner ears. During REM sleep, the brainstem sends signals that can activate vestibular pathways even while your body lies perfectly motionless. Research from 2025 used specialized vestibular monitoring to confirm that inner ear activation during sleep correlates strongly with dreams involving movement through space. This may explain why falling dreams feel so physically convincing, complete with the stomach-dropping sensation of genuine descent and the involuntary muscle jerk that sometimes follows. Your balance organs participate in the dream performance, even while your body rests completely still, like instruments that continue playing their part in an orchestra whose concert hall has gone dark. Keeping a written record of dreams over weeks and months reveals patterns that individual mornings cannot possibly show. Common themes surface repeatedly, with surprising regularity. Certain locations return again and again across different dream narratives. Emotional tones follow cycles that mirror the deeper rhythms of waking life in ways only long-term observation can reveal. Researchers who analyze extensive dream journals have discovered connections between dream content and significant life events that the dreamer may not have consciously recognized while awake. The discipline of recording dreams opens a window into the sleeping mind's persistent preoccupations. A diary written in a language that gradually becomes more legible the more carefully and patiently you attend to it. The ability to reflect on your own thinking, called metacognition, develops gradually within dreams just as it does in waking life. Research from 2025 found that young children rarely question dream events, no matter how strange. While adults occasionally notice something seems unusual even without achieving full lucid awareness, this partial dream metacognition appears to strengthen measurably with meditation practice and mindfulness training during waking hours. People who regularly observe their own thought patterns while awake show increased self-awareness within their dream experiences. The sleeping mind can learn to notice itself thinking, a quiet awakening within the dream that falls just short of lucidity, but represents a remarkable form of unconscious self-reflection, like a mirror that occasionally and unexpectedly catches its own image. Accounts of two people experiencing the same dream on the same night have appeared throughout recorded history, persisting across every culture and era without diminishing. While no scientific evidence currently confirms genuine dream sharing between separate minds, researchers acknowledge that close relationships often involve shared daily concerns and similar emotional experiences that might independently produce remarkably similar dreams. The question of whether sleeping consciousness can somehow overlap between individuals remains one of the most intriguing unknowns in dream science. Perhaps shared dreams reveal nothing more extraordinary than shared lives. Or perhaps they gesture toward aspects of sleeping awareness that current instruments cannot yet measure. Mysteries resting patiently at the very edge of what science can reach. Your body's temperature regulation changes dramatically during REM sleep, temporarily losing the ability to shiver when cold or sweat when warm. Research from 2025 discovered that this thermoregulatory suppression operates through the same brainstem mechanisms that produce the muscle paralysis of dreaming. If your sleeping environment grows too cold or too warm during a REM period, your body simply cannot adjust, potentially disrupting the dream phase entirely. This vulnerability may explain why comfortable bedroom temperatures matter so much for both dream quality and dream recall. Your dreaming brain trades temperature control for the freedom to generate impossible experiences. Like a vessel that lowers its sails to navigate waters, requiring a different kind of passage entirely. Sometimes you dream that you have woken up, risen from bed, and begun the familiar routines of your morning, only to discover with a start that you are still asleep. These false awakenings can chain together in remarkable sequences, creating layers of simulated waking that feel completely authentic at each stage. Bedroom environments are reproduced in striking detail. The sensations of swinging your legs over the edge of the mattress, of standing on a cool floor, of reaching for a light switch all feel genuine. Your brain demonstrates in these moments that it can construct not only fantastical adventures, but also perfectly ordinary reality, fabricating the mundane with the same extraordinary skill it applies to the impossible. False awakenings reveal something quietly profound about the nature of perception itself. If your sleeping brain can generate an experience of your own bedroom so convincing that you genuinely cannot distinguish it from waking reality, then perhaps your waking perception is also more of an internal construction than it ordinarily appears. Both experiences are ultimately generated by the same neural hardware, using the same fundamental processes. The difference is that waking perception uses sensory input from the external world as its raw material, while dreaming perception builds entirely from memory, expectation, and imagination. This realization gently blurs the boundary between what we call real and what we call imagined, suggesting that consciousness is always, in every state, actively creating the world it inhabits. Written text, clocks, and mathematical calculations seldom behave properly within dreams. Words shift and rearrange when you glance away and look back again. Clock faces display impossible times that change with every observation. Numbers stubbornly resist any attempt at addition or subtraction. These persistent failures reflect the reduced activity in prefrontal brain regions during REM sleep, the very areas that normally support careful, sequential, logical processing. The dreaming brain compensates brilliantly with imagery, emotion, and narrative momentum, but it simply cannot sustain the precise step-by-step operations that reading and arithmetic require. Dreams reveal which cognitive abilities depend most heavily on the waking brain's full resources. Like a city whose most delicate instruments only function properly when every power station is running. A 2025 theoretical framework called the dual process theory of dreaming proposes that two distinct neural systems contribute to dream formation simultaneously. The first generates raw emotional and sensory content through subcortical structures like the amygdala and thalamus. The second attempts to organize this material into coherent narrative using cortical regions. When the narrative system functions effectively, dreams feel story-like and internally logical, despite containing bizarre elements. When it struggles to keep pace, dreams become fragmented and disjointed. The balance between these two systems shifts continuously across the night, producing qualitatively different dream experiences in different sleep stages. Your dreaming mind works like two artists sharing one canvas, one painting with pure emotion and color, while the other tries to compose a recognizable scene from whatever forms appear. Research from 2025 revealed that the two hemispheres of your brain contribute differently to the experience of dreaming. The right hemisphere, associated with spatial processing, vivid imagery, and emotional interpretation, shows heightened activity during REM sleep. The left hemisphere, typically dominant for language and sequential logic during waking hours, becomes relatively quieter. This asymmetry may help explain why dreams communicate primarily through images, feelings, and spatial experiences rather than through words and careful reasoning. When verbal content does appear in dreams, it often feels approximate or slightly wrong, as though language is operating without its primary processing center fully engaged. Your dreaming mind leans naturally toward the hemisphere that speaks in pictures, like a conversation conducted entirely through paintings rather than paragraphs. The fundamental language of dreams is visual and emotional, rather than verbal or logical. Your sleeping brain communicates through scenes, symbols, spatial relationships, and felt sensations. A vocabulary far older than spoken language in evolutionary terms, where waking consciousness organizes experience through words, categories, and sequential reasoning. Dreaming consciousness creates meaning through juxtaposition, atmosphere, and something that can only be described as felt significance. Understanding dreams may require developing fluency in this profoundly different mode of thought, one that speaks directly to layers of the mind that verbal language cannot easily reach. Like learning to read a text written entirely in gradients of light and shadow, rather than letters arranged on a page. Whatever purposes dreams ultimately serve, they accomplish their essential work whether you remember them or not, whether you analyze their content or ignore it entirely. The emotional processing, the memory consolidation, the creative recombination of ideas all proceed without requiring your conscious participation or approval. Dreams do not wait for permission, and they demand no understanding in return. They simply unfold according to the sleeping brain's own deep logic, performing functions that have sustained every sleeping creature for millions of years without anyone needing to comprehend them. The invisible work continues faithfully regardless of your awareness of it, like rain falling steadily on soil that absorbs nourishment, whether or not anyone stands watching it descend. Dreams offer a rare and precious meeting point between the conscious and unconscious aspects of your mind. During waking hours, vast amounts of processing occur entirely beneath awareness, influencing your decisions, shaping your emotional responses, maintaining your body, all without ever surfacing into the light of consciousness. In dreams, some of this hidden activity becomes briefly visible, expressed through images, characters, and scenarios that the waking mind can sometimes recall upon rising. This nightly encounter between the known and unknown dimensions of yourself may be among dreaming's most profound gifts. A conversation between two aspects of the same mind that can only meet when the boundary between them softens in the gentle, permissive chemistry of sleep. Let us pause here for a moment and return to the simplest thing: your breathing. Notice how it continues without your guidance, rising and falling in a rhythm that existed before you were even aware of it. Each breath draws air into lungs that have expanded billions of times without your conscious permission. Each exhale releases warmth that was once moving through your blood, carrying oxygen to cells you have never seen. Feel the surface beneath you. Notice where your body makes contact with whatever holds you. The familiar pressure at the back of your head, along the width of your shoulders, the full length of your spine. These are places of trust, points where you have surrendered your weight to something solid without needing to think about it. Somewhere within you, right now, the same brain that constructs entire worlds each night is also keeping your heart beating, your blood circulating, your temperature steady. All of this happens in the most perfect silence, requiring nothing from your conscious mind. There is nothing to do, nothing to solve. Simply rest in the knowledge that you are held by processes older than memory itself. And when you feel ready, we continue. Your dreaming brain rarely replays memories exactly as they occurred during waking life. Instead, it takes elements from entirely different experiences and recombines them in novel, unexpected arrangements. The living room of your childhood home might suddenly contain colleagues from your current workplace. A conversation from last week might unfold on a beach you visited years ago with someone you have not thought about in decades. This creative reassembly is not a malfunction, but a deliberate feature. A system designed to discover connections between experiences that might otherwise remain forever separate in their original filing locations. Each night, your sleeping mind reshuffles the library of your entire life, placing books from different shelves side by side and discovering relationships that the orderly, categorizing waking mind would never have thought to investigate. This recombination of memory fragments during dreaming may serve the essential purpose of weaving new experiences into your existing web of knowledge. By connecting recent events to older memories in unexpected ways, your brain creates a richer and more interconnected understanding of the world and your place within it. A study from 2024 found that people who dream about recently learned material show significantly better retention and more creative application of that knowledge compared to those who do not incorporate it into dreams. The strange juxtapositions that make dreams feel bizarre may actually represent your brain's most sophisticated form of learning, weaving new threads into the existing tapestry in ways that strengthen the entire fabric through connections no conscious effort could have planned. The brain region responsible for processing sight remains intensely active during REM sleep, even though your eyes are closed and receiving absolutely no visual input from the external world. This internal activation generates the vivid imagery that characterizes dreams. When researchers use advanced monitoring during sleep, they find that specific visual processing areas activate in patterns that closely correspond to subsequently reported dream content. When dreamers describe seeing motion, the brain's motion processing areas light up on scans. When they perceive vivid colors, color processing regions respond precisely as they would to actual light. Dreams are built using the same neural architecture that constructs your perception of the waking world, which is precisely why they feel so convincingly, undeniably real. The correspondence between dream content and brain activation extends to remarkable levels of specificity. Research from 2025 used advanced functional imaging to demonstrate that when a sleeping person dreams of seeing a human face, the brain's dedicated facial recognition areas become active. When spatial environments appear in dreams, the navigation and spatial mapping centers respond. This means that dreams are not random internal noise, but carefully structured experiences generated by the same specialized neural circuits that process actual sensory information during the day. Your brain does not truly distinguish between externally and internally generated perception at the cellular level. The experience of a dream sunset may activate precisely the same circuits as a real one, making the distinction between dreaming and reality more of a philosophical question than a neurological boundary. Depriving someone specifically of REM sleep while allowing all other sleep stages to continue normally produces measurable increases in irritability, emotional volatility, and difficulty managing everyday stress. When those individuals are finally permitted to dream freely again, their REM sleep rebounds dramatically, occupying far more of the night than usual, as though the brain is urgently reclaiming something essential that it was denied. Research from 2025 confirmed that this emotional deterioration correlates directly with the precise amount of dreaming time lost. Whether dreams regulate mood through direct emotional processing or simply create the neurochemical conditions necessary for emotional recalibration continues to be debated. What remains certain is that your emotional equilibrium depends on dreaming as fundamentally as any garden depends on rain. Research from 2025 introduced the concept of emotional memory triage, suggesting that during REM sleep, your brain systematically sorts through the day's emotional experiences, deciding which deserve long-term preservation and which can safely be allowed to fade. Memories carrying the strongest emotional charge receive priority processing and consolidation, while emotionally neutral experiences are more likely to be gradually discarded. This triage system ensures that your most important emotional lessons, both the difficult ones and the joyful ones, are preserved for future reference while preventing your memory from becoming cluttered with thousands of insignificant daily moments. Your sleeping brain works like a careful archivist who reviews each day's entire correspondence, filing the most meaningful letters with care and gently releasing the rest into silence. Some scientists propose that dreams carry no inherent meaning whatsoever, representing merely the brain's attempt to construct a coherent story from essentially random neural firing during sleep. This activation synthesis hypothesis suggests that the brainstem generates chaotic electrical signals that cortical regions then scramble to interpret, much as we instinctively create explanatory narratives for unexpected events during waking life. According to this perspective, dream content reflects the brain's irrepressible storytelling impulse rather than any deeper biological purpose. Other researchers disagree strongly, pointing to substantial evidence that dreams serve memory consolidation, emotional regulation, and creative problem-solving. The debate continues earnestly in sleep laboratories around the world, each side presenting evidence that inches closer to a definitive answer that has not yet arrived. People who begin paying deliberate attention to their dreams consistently report remembering significantly more of them. This increase likely reflects heightened awareness during the brief moments after waking, rather than any actual increase in dreaming frequency. When you genuinely care about your dreams, you become more likely to notice them in those fleeting seconds before full wakefulness erases them, and more motivated to preserve the rapidly fading memories before they dissolve. Dream recall improves like any practiced skill. Within just a few weeks of keeping a journal beside the bed and writing immediately upon waking, most people report remembering multiple dreams per night, where before they recalled none. The experiences were always there, unfolding faithfully every night. Only your attention has changed. The subjects and themes that populate your dreams shift predictably across the course of your life. Young adults frequently dream about romantic connections, social encounters, academic challenges, and personal achievement. People in their middle years dream more often about family responsibilities, professional pressures, and health concerns. In later life, dreams tend to revisit the past more frequently, encounter loved ones who have died, and explore themes of transition, meaning, and completion. Dreams remain faithfully engaged with whatever matters most during each particular chapter of existence, processing the specific concerns and quiet joys that define every stage. Your sleeping mind keeps close, attentive pace with the changing landscape of your waking life, never falling behind. A 2025 longitudinal study found that the complexity and richness of dreams correlates closely with overall cognitive engagement and mental flexibility during waking hours. People who regularly participate in creative, intellectually stimulating, or emotionally challenging activities tend to report more elaborate, narrative-rich, and symbolically dense dreams. Conversely, extended periods of mental routine or unstimulating repetition may produce simpler, more repetitive dream content with less emotional range. The dreaming mind appears to exercise whatever cognitive capacities are most active during the day, stretching and strengthening the same mental muscles you use while awake. Your dreams serve as a kind of overnight training session for whatever skills you practice most, like an echo that returns richer and more complex than the original sound that created it. Dreams that repeat themselves, returning in the same or remarkably similar form across weeks, months, or even years, affect approximately 2/3 of all adults at some point during their lives. These recurring visitors often involve themes of being pursued, of falling endlessly, or of facing some threatening situation that never quite reaches resolution no matter how many times it replays. Researchers believe they may reflect ongoing concerns or unresolved emotional tensions in waking life that the dreaming mind continues attempting to process without success. The dream persists because the underlying issue persists. Some people report that long-standing recurring dreams finally cease altogether after they consciously address the waking concern that seemed connected to the repeated imagery, as though the sleeping mind no longer needs to rehearse what consciousness has finally had the courage to confront. Dreams during pregnancy frequently become more vivid, more emotionally intense, and considerably easier to remember upon waking. Hormonal shifts, significantly altered sleep architecture, and the profound emotional weight of expecting a child all contribute to this remarkable transformation of the dreaming landscape. Many expectant parents report dreams about babies, about the experience of birth, and about their fundamentally shifting sense of identity as they prepare for an entirely new chapter. Dream themes tend to evolve noticeably across the 3 trimesters, following the distinct concerns and anticipations of each stage. The sleeping mind keeps faithful pace with the body's profound transformation, processing the psychological dimensions of a change that extends far beyond the physical. When the mind encounters experiences too intense for normal processing to handle, nightmares may become trapped in a repetitive cycle, replaying or symbolically revisiting the overwhelming event night after night. These trauma-related nightmares differ from ordinary unpleasant dreams in their raw intensity, their tendency to shatter sleep entirely, and their stubborn resistance to the gradual emotional fading that normally accompanies difficult experiences over time. The dream system that ordinarily helps regulate emotions becomes overwhelmed by material too intense to integrate through standard overnight processing. Effective therapeutic approaches now address nightmares directly, teaching people to consciously revise the nightmare script while fully awake, offering the sleeping mind a different narrative path and a gentler ending to practice. Across cultures and throughout all of recorded history, sharing dreams with others has served as a powerful form of social bonding and trust building. Research from 2025 examined communities where regular morning dream sharing is an established cultural practice and found that participants consistently reported stronger interpersonal connections and greater feelings of being genuinely understood by their peers. The act of narrating a dream requires a particular kind of vulnerability, revealing the unguarded, uncensored productions of a sleeping mind to someone else. When received with curiosity and warmth rather than judgment, this sharing strengthens the foundation of trust between people. Your dreams, though entirely private in their creation, may have evolved partly to become shared stories, like experiences that gain their fullest meaning only when they find a patient, listening ear. A collection of brain regions called the default mode network, which activates during daydreaming and mind-wandering in waking life, shows significant and sustained activation during REM sleep. This network supports internal mental activity when attention is not required for processing the external world. Its prominent presence in both waking reverie and sleeping dreams suggests a deep kinship between these two seemingly different states of consciousness. Daydreams and night dreams may share far more than merely their names, both emerging naturally when the mind turns inward, freed from the constant demands of interpreting and responding to sensory information. The same neural architecture that carries you through idle moments gazing out a window carries you equally through the landscapes of your deepest sleep. Time within dreams does not always correspond to time passing in the physical world. Some dream events unfold at roughly the pace of waking experience, moment for moment. Others compress dramatically or expand in ways that feel perfectly natural within the dream, but seem physically impossible upon waking reflection. 5 minutes of subjective dream time might correspond to vastly different durations of actual sleep, depending on the nature of the experiences being generated. The sleeping brain maintains its own sovereign relationship with time, completely unconstrained by external clocks or measurable intervals. Sometimes dreams contain what feel like entire lifetimes within minutes. Other times, a single suspended moment stretches into what seems like hours, like light bending as it passes through still water on its way to somewhere deeper. Dreams experienced during brief daytime naps differ measurably from those occurring during full overnight sleep. Research from 2025 found that nap dreams tend to be shorter, less emotionally complex, and more directly connected to very recent waking experiences than their nighttime counterparts. They also display significantly less of the bizarre, creative recombination that characterizes longer REM dreams occurring in the second half of a full night. This difference may arise because nap dreams occur at a different point in the circadian cycle, when brain chemistry differs substantially from nighttime conditions. The deep creative restructuring that makes night dreams so strange apparently requires the specific neurochemical environment that only extended overnight sleep can provide. Your afternoon dreams are pencil sketches where your night dreams are fully rendered, deeply colored paintings. Although vision dominates the vast majority of dream reports, dreams can engage every sensory modality the brain has ever learned to process. Sound appears commonly, from overheard conversations to fragments of music to ambient environmental noise. Touch sensations, proprioceptive movement, and vivid spatial awareness are frequently described. Taste and smell surface less often, but are clearly experienced by many dreamers when they do appear. The intensity and variety of sensory experience varies considerably across both individuals and individual dreams. Some people inhabit predominantly visual dreamscapes with minimal additional sensory input. Others report rich, fully immersive multisensory environments where they can feel grass texture beneath bare feet, hear wind through leaves overhead, and smell approaching rain from miles away. The cultural context in which you live shapes both how you interpret your dreams and, perhaps more surprisingly, what you actually dream about. Societies that regard dreams as sacred communications from ancestors or spiritual dimensions tend to produce dreamers who recall more content and assign far greater personal significance to their nocturnal experiences. Cultures that dismiss dreams as meaningless neural static typically produce less dream recall and less deliberate engagement with dream material. Research from 2024 found that these cultural frameworks influence not only conscious interpretation, but the dreaming experiences themselves. As though the sleeping mind draws from the full library of cultural knowledge and expectation when selecting materials and themes for its nightly constructions. Despite the enormous diversity of specific dream content across world cultures, research from 2025 found remarkably consistent underlying narrative structures in dream reports collected from every continent. Dreams tend to follow a universal pattern of setting establishment, developing complication, and emotional movement towards some form of resolution or suspension. This universal dream grammar suggests that narrative organization itself may be a fundamental, built-in function of the dreaming brain, shaping raw experience into meaningful sequences, regardless of the dreamer's cultural background or personal history. Your sleeping mind is a storyteller following structural rules that predate every human literary tradition. An ancient narrator who shapes the raw material of experience into tales using a grammar written directly into the architecture of the brain itself. Smell. Though among the rarest sensory experiences explicitly reported in dream research, may play a more significant role in shaping dreams than previously recognized. Research from 2025 found that presenting pleasant or unpleasant odors to sleeping subjects during confirmed REM periods reliably influences the emotional tone of their dreams without waking them. Pleasant fragrances produced more positively toned dream narratives, while unpleasant chemical scents increased negative and anxious dream content. Intriguingly, the dreamers themselves rarely reported actually smelling anything specific upon waking, suggesting that the olfactory input was seamlessly translated into mood and emotional atmosphere rather than conscious sensory perception. Your nose continues quietly monitoring the world, even during your deepest sleep, coloring your dream experiences with emotional responses to scents your conscious mind never registers. The brief electrical bursts called sleep spindles, occurring during lighter sleep stages, appear to directly influence the dreams that subsequently emerge during deeper REM periods. Research from 2024 found meaningful connections between spindle activity occurring after learning new information and the later incorporation of that learned material into dream narratives. This finding suggests that the brain's memory processing work during lighter sleep stages feeds directly into the stories that deeper sleep constructs. The different stages of sleep may cooperate far more closely than scientists once believed, each contributing its specialized part to an integrated overnight process considerably more coordinated and purposeful than anyone initially imagined. Dreams draw from two fundamentally distinct types of memory. Episodic memories record specific personal experiences, while semantic memories contain general knowledge about how the world works. Research from 2025 found that the balance between these two sources shifts systematically across the night. Earlier dreams tend to incorporate more recent episodic memories, fragments of the day's personal experiences woven into recognizable settings. Later dreams increasingly draw from semantic knowledge and much older personal experiences, creating more abstract and symbolically rich narratives as morning approaches. This progression may reflect your brain's natural memory consolidation strategy. First, processing the raw material of recent events, and then gradually integrating it with the broader, deeper understanding accumulated over a lifetime. Your dreams shift from intimate diary entries towards something closer to encyclopedia passages as the night unfolds. When your sleeping brain replays experiences from the day, it frequently does so at dramatically accelerated speeds invisible to conscious experience. Research from 2025, using advanced neural recording techniques, found that patterns of brain activity associated with daytime learning replay during sleep at rates 5 to 20 times faster than they originally occurred. This remarkable compression may allow the brain to review and consolidate vast quantities of information with extraordinary efficiency within the limited time available for each sleep cycle. The acceleration remains completely invisible within the subjective dream experience itself. Your sleeping mind reviews the day in a kind of fast-forward that you can never perceive. Like a librarian who can absorb the contents of an entire book simply by running a finger along its spine in the dark, the threshold between wakefulness and dreams remains permeable in both directions, each state quietly influencing the other in ways you may never fully trace. What you do and feel before sleep shapes the raw material of your dreams. What you dream may shape the emotional tone that greets you upon waking. Feelings generated in dreams linger into the first hours of morning. Insights that germinated during sleep surface unexpectedly during the afternoon. The two states of consciousness are separated not by a solid wall but by something more like a translucent curtain, thin enough to allow light and sound and meaning to pass through in both directions, each side gently coloring the other in patterns too subtle and intricate to ever fully map. You are still here, still resting, still drifting with these quiet truths about your dreaming mind. Let yourself settle even deeper into wherever you lie. Notice how your body has grown subtly heavier since we began, not with burden, but with the gentle, welcome weight of genuine release. Every muscle that was holding unnecessary tension has been quietly, gradually letting go without your needing to direct it. Bring your awareness to the space behind your closed eyes. There is a soft darkness there, not empty but alive, with the faintest impressions of warmth and shifting color. This is the same darkness that will become your dreaming canvas tonight. It holds infinite potential, waiting for sleep to set it free. Feel the steady, faithful rhythm of your heart. It has been beating throughout this entire journey, never pausing, never asking for acknowledgement or gratitude. In its quiet, tireless persistence, there is something deeply, profoundly reassuring all around you. The night is doing its patient, invisible work, and you are part of that work simply by resting here, simply by being still. Let the next words carry you further into the quiet. There is no hurry at all. Certain dream themes appear with remarkable consistency across cultures, throughout history, and regardless of individual circumstance. Falling through empty space, being pursued by something unseen, appearing unclothed before strangers, discovering your teeth crumbling, arriving desperately late for something important. These experiences emerge in dream reports collected from every inhabited continent and every recorded era. Their universality suggests that dreams tap into concerns rooted deep within our shared biology, rather than arising solely from personal experience. The fear of falling may echo ancestors who slept in elevated places. Being chased reflects millennia of vulnerability to predators. These common dream visitors reveal something fundamental about the architecture of the human mind. Fears written so deeply into our nature that they surface in every sleeping brain. Flying dreams are among the most frequently reported positive dream experiences across all cultures studied. In these dreams, people soar through open air, sometimes by swimming motions, sometimes by simply willing themselves upward with a thought. The sensation frequently carries powerful feelings of liberation, joy, and exhilaration that linger into waking hours. Researchers suggest that flying dreams may represent feelings of personal empowerment or a deep desire to transcend constraints experienced during waking life. The specific manner of flight and the emotional tone accompanying it may reflect the dreamer's current psychological state. Some experience flying as purely liberating. Others find unexpected fear in the height. The dream itself is universal, but the meaning it carries shifts with whoever is dreaming it, like wind that feels different depending on where you stand. Nightmares serve purposes that extend beyond their distressing surface. One prominent theory proposes that nightmares help process genuine fears by allowing rehearsal of emotional responses within an environment where no real harm can occur. Another suggests that nightmares arise when the emotional processing function of dreams encounters material too intense to integrate smoothly in a single night. Research from 2024 found that frequent nightmares correlate strongly with waking anxiety, unresolved stress, and experiences that have overwhelmed normal coping. Therapeutic approaches that guide people in consciously rewriting their nightmare narratives while awake have demonstrated remarkable success in reducing both nightmare frequency and their emotional impact. The sleeping mind that generates your worst dreams may be attempting its own form of healing, reaching toward resolution through the only language available to it. Lucid dreaming occurs when you become aware that you are dreaming while still remaining within the dream itself. This extraordinary state merges the immersive sensory experience of dreaming with the self-awareness typically reserved for waking consciousness. During lucid dreams, some people discover they can influence dream events, choosing where to travel, what to explore, and how to respond to whatever the dream presents. Brain scans of confirmed lucid dreamers reveal increased activity in the prefrontal cortex, the same region that normally falls quiet during ordinary dreaming. This partial reactivation of logical, self-aware brain areas appears to enable the remarkable recognition that the vivid experience currently unfolding is, in fact, a dream. Lucid dreaming can be cultivated through practice, though most people find it requires patience and sustained attention, like learning to hear a whisper within a symphony. The discovery of REM sleep in 1953 fundamentally transformed the scientific study of dreams. Before this breakthrough, researchers had no reliable method for identifying when dreams were actually occurring during sleep. Scientists Eugene Aserinsky and Nathaniel Kleitman observed that sleeping subjects displayed periodic bursts of rapid eye movements throughout the night, occurring in predictable cycles. When participants were awakened during these REM periods, they almost universally reported vivid, detailed dream experiences, This finding provided science with its first objective window into the dreaming brain, allowing systematic investigation of when dreams occur, how long they persist, and what neural processes accompany them. The study of dreams, once confined entirely to philosophical speculation and morning recollections, could finally be pursued with the precision and rigor of laboratory science. How well you remember your dreams depends significantly on when and how you happen to wake. If consciousness returns during or immediately following a REM period, dream memories are far more likely to survive the transition into wakefulness. Waking from deep, dreamless sleep stages typically leaves no dream trace at all. The jarring interruption of an alarm clock may actually steal your dreams by disrupting the natural, gradual waking process that allows dream memories to consolidate. People who wake slowly and allow themselves a few motionless moments before rising, letting memories settle before the day's demands begin, tend to recall considerably more dream content. The memories exist. They simply require a gentle, unhurried passage from sleep to wakefulness to survive the crossing. Your sleeping brain continuously monitors the external environment and weaves relevant sensory information into the ongoing dream narrative with remarkable seamlessness. A doorbell ringing in the physical world might become a telephone in the dream. Temperature changes in the bedroom might manifest as dream weather shifting from warm to cold. The sound of rain on a window might become a waterfall in the dreamscape. This incorporation typically maintains the dream's internal coherence, translating external events into forms appropriate for the current narrative without breaking the dream's illusion. Researchers have exploited this phenomenon to study dreams experimentally, presenting specific sounds or scents to sleeping subjects and examining how these stimuli appear transformed in subsequent dream reports. The dreaming mind is never completely sealed off from the world outside. When people are prevented from sleeping and then finally permitted to rest, they display a phenomenon called REM rebound, spending significantly more time in REM sleep than they normally would. This compensatory increase suggests that REM sleep and the dreaming it contains serve functions important enough that the brain actively prioritizes recovering them when given the opportunity. People experiencing severe, prolonged sleep deprivation sometimes report dreamlike hallucinations while still technically awake, as though the biological pressure to dream grows so powerful that it eventually breaks through into waking consciousness. Your brain appears to need its dream time with a persistence that borders on insistence, and it will find ways to claim that time, regardless of whether your conscious mind cooperates. Pharmaceutical substances can dramatically reshape the landscape of your dreams. Certain antidepressant medications suppress REM sleep and significantly reduce dream recall. Other compounds, particularly those affecting the neurotransmitters dopamine or acetylcholine, can intensify dreams considerably or trigger vivid nightmares. People discontinuing REM-suppressing medications frequently experience an intense surge of vivid, emotionally charged dreams as the brain rebounds into increased dreaming activity. Even common substances alter dream experiences. Alcohol initially suppresses REM sleep during the first hours after consumption, but as it metabolizes through the night, REM rebounds strongly, often producing strange, unsettling, or emotionally vivid dreams during the early morning hours. The chemistry flowing through your brain directly sculpts the character, intensity, and emotional tone of every dream you experience. People who are blind dream in ways that depend entirely on when vision was lost. Those who have been blind since birth or very early childhood dream primarily through other senses, experiencing rich landscapes of sound, touch, texture, taste, and spatial awareness, without any visual imagery whatsoever. Those who lost sight later in life often continue dreaming in visual images, particularly of familiar places and beloved faces known before vision departed. As years and decades pass, visual elements may gradually diminish in frequency and vividness. This finding reveals that dream imagery is constructed from the raw materials that lived sensory experience has provided to the brain. The visual processing centers need actual visual experience during their developmental period to generate visual dreams later. Dreams are built from whatever the senses have gathered across a lifetime. Animals almost certainly experience their own version of dreaming. REM sleep has been observed and confirmed in every mammal studied by researchers, as well as in birds and, more recently, in certain reptile species. During REM periods, animals display muscle twitches, rapid eye movements, and brain activity patterns strikingly similar to those observed in sleeping humans. Cats with specific brainstem modifications that prevent normal REM paralysis physically act out what appear to be elaborate hunting behaviors during sleep. Laboratory rats show neural replay of patterns associated with maze navigation while sleeping after learning new routes. The sleeping brains of animals appear to process and rehearse experiences in ways remarkably parallel to human dreaming. Your cat curled peacefully beside you is very likely dreaming its own feline adventures, chasing prey through landscapes only it will ever see. The emotional character of dreams typically shifts in a predictable pattern across the night. Dreams occurring during earlier sleep cycles often address recent practical concerns and tend to carry a more neutral or mildly negative emotional tone. Dreams from later cycles, emerging during the longer REM periods that characterize the second half of the night, become progressively more emotionally intense, more narratively bizarre, and frequently more positive in feeling. The morning hours just before waking typically produce the most vivid, elaborate, and emotionally rich dream experiences of the entire night. This shift may reflect the brain's changing neurochemistry as stress hormones gradually decline and other neurotransmitter systems fluctuate through their natural cycles. The dreams that greet you in the final hours before dawn are the most fully orchestrated compositions your sleeping mind creates. Research from 2025 explored how body position during sleep subtly influences dream content. People sleeping on their right side reported slightly more positive emotional tones in dreams compared to left-side sleepers, possibly due to differences in autonomic nervous system activation between positions. Sleeping face down was associated with more dreams involving pressure, restriction, and themes of being trapped or unable to move. Back sleepers reported more frequent episodes of sleep paralysis and nightmares. While the effects are subtle and do not override other dream-determining factors, your physical orientation while sleeping appears to contribute one additional variable to the complex equation that produces each night's unique dream experiences. Like a gentle current beneath the surface that nudges without commanding, the sleeping brain generates authentic emotions that are neurologically indistinguishable from those experienced during waking life. Fear in nightmares activates the same amygdala circuits as genuine danger. Joy in pleasant dreams produces real neurochemical signatures of happiness. Grief experienced in dreams about lost loved ones generates actual tears from tear ducts that respond to emotional signals regardless of whether the triggering event is real or imagined. These dream emotions are not pale simulations, but full-bodied experiences manufactured by the same biological machinery that creates feelings during waking hours. The sleeping brain feels with the same depth and authenticity as the waking brain, sometimes even more intensely, because the logical systems that normally moderate emotional responses have temporarily dimmed their influence. Your gut microbiome, the trillions of bacteria inhabiting your digestive system, appears to influence dream content through the gut-brain axis. Research from 2025 found that people with more diverse and balanced gut bacterial communities reported fewer nightmares and more emotionally neutral or positive dreams. Since gut bacteria produce approximately 90% of the body's serotonin and significantly influence inflammation, their composition may affect the neurochemical environment in which dreams unfold. Dietary changes that alter gut bacteria have been associated with shifts in dream quality within as little as 2 weeks. The microorganisms living quietly in your abdomen may participate in shaping the stories your brain tells itself at night. Invisible collaborators, contributing to the emotional palette of your sleeping world. The process by which dream memories are lost upon waking, called dream amnesia, involves specific neurological mechanisms that researchers are only now beginning to understand in detail. Research from 2025 identified neurons in the hypothalamus that actively suppress dream memory formation during REM sleep, producing a chemical environment that prevents the hippocampus from properly encoding dream experiences into lasting storage. This suppression appears to be deliberate rather than accidental, suggesting that forgetting dreams may serve a protective function. If every dream were remembered with the same clarity as waking experiences, distinguishing genuine memories from dream memories could become increasingly difficult over time. Your brain may actively choose to let most dreams dissolve, protecting the integrity of your waking memory by keeping the two streams of experience carefully separate. During REM sleep, your brain demonstrates enhanced capacity for analogical reasoning, finding meaningful similarities between seemingly unrelated concepts. Research from 2025 tested participants on creative problem-solving tasks before and after sleep and found that REM sleep specifically improved the ability to identify hidden connections between disparate ideas. This enhancement appears linked to the loosened associations that characterize dreaming consciousness, where the usual categorical boundaries maintained by waking thought relax enough to allow unexpected connections to form. Your sleeping brain excels at finding the thread that connects a seashell to a galaxy, a heartbeat to ocean waves, a falling leaf to the passage of time. These analogical leaps, impossible under the stricter logic of daytime thinking, may represent one of dreaming's most valuable creative contributions. Hormonal fluctuations throughout the menstrual cycle measurably influence dream content and emotional intensity. Research from 2025 found that dreams during the luteal phase, when progesterone levels peak, tend to be more emotionally vivid and contain more interpersonal and social themes. Dreams during the follicular phase show different characteristics, often featuring more physical activity and spatial exploration. These patterns suggest that the hormonal environment in which sleep occurs directly shapes the raw material available to the dreaming brain. Your dreams are not only influenced by what you experience and think about, but also by the invisible chemical tides flowing through your body, each cycle bringing its own distinct coloring to the nightly canvas. the vividness and memorability of dreams follows circadian rhythms, independent of how much sleep you have accumulated. Research from 2025 found that dreams occurring during the biological morning, when your circadian clock promotes lighter sleep and increased cortical activation, are consistently more vivid and easier to recall than dreams occurring during the biological night. This means that napping during morning hours may produce more memorable dreams than napping in the afternoon. Regardless of sleep duration, your internal clock influences not just when you sleep, but the quality and character of the dreams that sleep contains, adding another layer of invisible orchestration to an already remarkably complex process. Sensory deprivation. The deliberate reduction of external sensory input has been shown to intensify subsequent dream experiences significantly. Research from 2025 found that participants who spent several hours in reduced sensory environments before sleeping reported markedly more vivid, emotionally intense, and creatively bizarre dreams compared to control groups. The brain, deprived of its usual external stimulation, may compensate by generating more elaborate internal experiences during sleep. This finding suggests that the dreaming brain's creative output responds to the sensory diet of waking hours, becoming more inventive when external input has been scarce. Your dreams may grow most vivid precisely when the waking world has offered the least, like flowers that bloom most extravagantly in the poorest soil. Researchers have developed techniques for deliberately re-entering a specific dream after brief waking, a practice called dream re-entry. By lying still upon waking from a dream, keeping eyes closed, and gently focusing attention on the fading dream imagery without forcing or grasping, some people can successfully return to the interrupted dream narrative. Studies from 2025 found that this skill improves significantly with practice and correlates with greater mindfulness ability during waking hours. Dream re-entry offers a unique opportunity to continue exploring a dream that felt meaningful or unfinished, allowing the conscious and unconscious minds to collaborate on processing whatever the dream was addressing. Like returning to a book you set down mid-chapter, finding the page still open and the story waiting patiently for your attention. You might be feeling quite drowsy now. That is perfectly fine, perhaps even welcome. Notice your body one more time, how different it feels from when we began. The muscles of your face have softened. Your hands lie open and relaxed. Your breathing has found a rhythm so natural it barely registers as something you are doing. Consider for a moment the vast darkness inside your own skull. It is a space no larger than 2 fists held together. Yet within it, entire universes are constructed each night. Cities rise and dissolve. Oceans stretch to horizons that exist nowhere outside your neurons. People speak words that no one has ever spoken before, and no one will ever hear again. All of this happens in perfect, complete privacy. Your dreams are the most intimate creations in existence. Experiences made for an audience of exactly one. Let that thought settle over you like a blanket. You are a universe unto yourself, and tonight, that universe will fill with wonders. We are nearly there now. Let us continue into the final stretch together. Based on careful scientific estimates, you will spend approximately 6 full years of your life immersed in dreams. Assuming roughly 2 hours of REM sleep each night accumulated across an average lifespan. Every single night, whether you retain any memory of it or not, your brain generates multiple complete dream experiences across several sleep cycles. Most people produce between 4 and 6 distinct dreams per night. though the overwhelming majority slip entirely from consciousness upon waking, without leaving the faintest trace. By the time you reach old age, you will have spent over 2,000 days inhabiting dream states, experiencing countless adventures, emotions, and visions that existed only within the private theater of your sleeping mind. Dreams are not rare occurrences reserved for special nights. They are a constant, faithful companion present every single night, whether acknowledged or not. Dreams emerge primarily during a sleep phase called REM, named for the rapid eye movements that characterize it. During these periods, your eyes shift gently back and forth beneath closed lids, as if watching invisible scenes play out in slow, deliberate motion. Your brain becomes remarkably active during REM, displaying electrical patterns on monitoring equipment that closely resemble full wakefulness. Yet, simultaneously, your voluntary muscles remain almost completely paralyzed through a protective mechanism that prevents you from physically acting out whatever your dream self is experiencing. This paralysis, mediated by specific neurons in the brainstem, keeps you safely at rest while your mind soars through landscapes that feel absolutely real. REM periods recur approximately every 90 minutes throughout the night, with each successive period growing longer as morning approaches. Your most vivid and elaborate dreams typically unfold in the final hours before waking. The prefrontal cortex, the brain region responsible for logical reasoning, critical evaluation, and distinguishing reality from imagination, becomes remarkably quiet during REM sleep. This region normally functions as your internal reality checker, constantly evaluating whether situations make sense, whether events are plausible, and whether your responses are appropriate. When it partially deactivates during dreaming, you lose the capacity to question even the most impossible scenarios. Pink elephants marching through your kitchen seem perfectly reasonable. Time flows backward without raising concern. You might attend important meetings wearing nothing at all without experiencing the slightest alarm. The sleeping brain accepts whatever narrative unfolds with complete trust, because the very systems designed to detect impossibility have temporarily, voluntarily stepped aside, like a guard who leaves the gate unattended knowing that tonight, no real danger can enter. While your logical faculties rest, the emotional processing centers of your brain surge to heightened activity during REM sleep. The amygdala, a small almond-shaped structure nestled deep within each hemisphere, shows substantially increased activation during dreaming compared to quiet wakefulness. This elevated emotional processing explains why dreams so often carry intense feeling that seems disproportionate to their content. Fear in nightmares can feel more terrifying than any waking anxiety. Joy in pleasant dreams carries a purity that daytime happiness rarely achieves. Grief over dream losses produces genuine tears that dampen actual pillows. These dream emotions are not faded copies of real feelings. They are authentic neurological experiences generated by the identical brain structures that create emotions during your waking hours, sometimes burning even brighter because the moderating influence of logical thought has been temporarily withdrawn. Your hippocampus, a curved structure deep within the temporal lobe named for its resemblance to a seahorse, serves as the brain's primary memory processing center and plays a fascinating dual role during sleep. Throughout the night, it replays fragments of recent experiences, forwarding information to cortical regions for long-term consolidation and storage. However, The hippocampus performs this consolidation function poorly for the dream experiences themselves. This is precisely why dreams fade so rapidly upon waking, dissolving like frost in morning sunlight. Your brain appears to treat dream events as temporary working experiences not intended for permanent recording. Unless you wake during or immediately after a dream and consciously rehearse its contents before they dissipate, the memory evaporates, leaving behind only fragments or nothing whatsoever, like words written on the surface of water. Accumulating evidence suggests that dreams actively help process emotional experiences and gradually reduce their overwhelming intensity over time. When you encounter something stressful or emotionally charged during the day, your brain may replay these events during REM sleep, but within a fundamentally different chemical environment. Stress hormones, particularly norepinephrine, fall to their absolute lowest concentrations during REM periods, creating conditions where difficult memories can be revisited without triggering the full physiological stress response that accompanied the original experience. This chemical separation may allow the brain to examine troubling events from a safer neurological distance, gradually stripping away the raw emotional intensity while preserving the factual content of what occurred. Dreams may function as a gentle form of overnight therapy, processing what the waking mind found too heavy to carry alone. Not every dream emerges from REM sleep. Researchers have confirmed that dreams can arise from virtually any sleep stage, though they differ markedly in quality and character depending on their origin. REM dreams tend to be vivid, narratively complex, and populated with bizarre scenarios and impossible events. Dreams arising from non-REM sleep stages are generally more mundane, resembling ordinary thoughts, brief impressions, or simple replays of recent activities rather than elaborate stories. You might dream of folding laundry or having a straightforward conversation during lighter sleep, without any of the surreal transformations that characterize REM dreams. These simpler experiences occur throughout the night but are forgotten with particular ease. The dramatic, memorable dreams that most people think of when they hear the word dream usually emerge from REM periods, particularly those occurring in the second half of the night, when REM episodes reach their greatest length and intensity. Your brain generates genuine motor commands during dreaming, complete signals to run, reach, speak, and grasp. But a protective system in the brainstem actively blocks these commands from reaching your voluntary muscles. In some individuals, this paralysis mechanism malfunctions, producing a condition called REM sleep behavior disorder. Those affected physically move during their dreams with sometimes startling energy and coordination, punching, kicking, leaping from bed, or calling out while remaining completely asleep. This condition reveals something remarkable about the nature of dreams. When you dream of running, your brain truly intends for your legs to move. When you dream of speaking, your motor cortex sends authentic speech commands. Only the paralysis system prevents these internal intentions from becoming external actions. Your dream body and your physical body share the same command center, separated only by a chemical gate that opens each morning when dreaming ends. The content of your dreams often mirrors the preoccupations and emotional concerns of your waking life, a pattern researchers have formalized as the continuity hypothesis. If your days are consumed with worry about an upcoming presentation, your dreams may feature scenarios of public speaking, unpreparedness, or social evaluation. If you are learning a new instrument, you might dream of playing music. Studies from 2024 confirmed that people reliably incorporate recent waking experiences into their dreams, though almost never as exact replays. Instead, dreams remix and transform elements, combining fragments of yesterday with memories from years ago, creating scenarios that feel simultaneously familiar and entirely strange. Your waking concerns do not simply vanish when you close your eyes. They take on new and often unrecognizable forms, processed through the unique creative logic of the sleeping mind. Scientists can now predict certain aspects of dream content by carefully monitoring brain activity during sleep. Using sophisticated functional imaging and machine learning algorithms, researchers have identified distinct patterns of neural activation that correspond to specific visual elements appearing in dreams. When participants dream of human faces, the brain regions specialized for face recognition become reliably active. When they dream of navigating through physical spaces, spatial processing areas activate in characteristic patterns. These findings, confirmed through 2025 research, demonstrate conclusively that dreams are not formless neural noise, but highly structured experiences built by the same specialized processing systems that handle real-world sensory perception. Your dreaming brain constructs its impossible worlds using the same precise architectural tools it uses to perceive the real one. Dreams have contributed to creative breakthroughs and problem-solving throughout recorded human history. The loosened associative networks of REM sleep allow the brain to forge novel connections between concepts that would seem entirely unrelated to the discipline. Categorizing waking mind. Research from 2024 documented numerous cases where people who struggled persistently with complex problems during the day discovered working solutions embedded within their dreams. The early twilight state of sleep onset, called hypnagogia, appears to be particularly fertile ground for creative insight. People who briefly enter this transitional state and then wake show measurably enhanced creative performance on subsequent tasks. The sleeping mind explores possibilities that waking logic would never permit itself to consider, wandering through forbidden corridors and opening doors that the rational mind keeps permanently locked. The dreams of children differ profoundly from those of adults in ways that illuminate the developmental nature of dreaming itself. Young children frequently dream in static images rather than flowing narratives, experiencing snapshots rather than stories. Their dream characters may not include themselves as active participants until approximately age 7 or 8, when self-representation in dreams begins to emerge. As cognitive abilities develop and mature during childhood, dreams progressively become more complex, more narratively structured, and more self-aware. Research from 2025 confirmed that the development of dreaming closely parallels the development of waking cognitive capacities. Children who demonstrate more advanced thinking skills while awake consistently produce more elaborate dream experiences. Dreams are not randomly assigned at birth. They grow and deepen alongside the mind that creates them. Targeted memory reactivation, a technique where specific sounds or scents associated with daytime learning are presented during sleep, has been shown to selectively strengthen related memories and influence dream content. Research from 2025 demonstrated that playing quiet cues linked to specific learned material during slow-wave sleep significantly improves retention of that material compared to uncued memories. Some participants reported dreams that incorporated the cued content, suggesting a direct pathway from external stimulation through sleep processing into dream narrative. This technology raises fascinating possibilities for deliberately shaping both memory consolidation and dream experience. The sleeping brain remains receptive to carefully chosen whispers from the waking world, like a garden that responds to specific nutrients applied to its soil while the gardener sleeps above. As the human brain ages, its sleep architecture transforms in ways that directly alter the dreaming experience. Older adults spend proportionally less time in REM sleep and experience shorter, less intense REM periods compared to younger individuals. Research from 2025 found that these changes correlate with shifts in dream character, including less emotional intensity, fewer bizarre elements, and more frequent incorporation of distant memories and deceased loved ones. However, dream recall often decreases with age, making it difficult to determine whether dreams truly change or simply become harder to capture upon waking. The aging brain continues to dream faithfully every night, but the nature of those dreams evolves gradually. Like a landscape that shifts so slowly, you only notice the change when you compare photographs taken years apart. The glymphatic system, a waste clearance network discovered in the brain, operates most efficiently during sleep and may directly influence dream quality. During deep sleep, brain cells shrink slightly, widening the channels between them and allowing cerebrospinal fluid to flush metabolic waste products more effectively. Research from 2025 found that people with more efficient glymphatic function report clearer, more coherent dreams, and better dream recall. Impaired waste clearance is associated with fragmented, confusing dream experiences and difficulty remembering dreams upon waking. Your brain's overnight cleaning system may need to complete its work before the dreaming mind can operate at full creative capacity. Like a theater that must be swept clean before the actors can perform on its stage. Sleep following a difficult decision has been shown to improve both the quality of the choice made and the dreamer's confidence in that choice. Research from 2025 found that complex decisions benefit from overnight processing, with REM sleep specifically enhancing the integration of emotional and rational factors that inform good judgment. Participants who slept between encountering a difficult choice and making their final decision showed measurably better outcomes than those who decided immediately or after equivalent time spent awake. Dreams may contribute to this improvement by allowing the sleeping brain to simulate potential outcomes and evaluate their emotional consequences without real-world stakes. Your wisest decisions may owe something to the invisible counsel of dreams you never remember having. Dreams about music are reported by approximately 40% of people, with musicians and regular music listeners experiencing them most frequently. Research from 2025 found that musical dreams can include original compositions that the dreamer has never consciously created, suggesting that the sleeping brain possesses genuine creative capacity in auditory domains. Some historically documented musical works were reportedly inspired by melodies first heard in dreams. The auditory processing regions of the brain remain active during REM sleep, capable of generating complex sound experiences without any external acoustic input. Your sleeping mind can compose symphonies in silence, hear orchestras in empty rooms, and create melodies that have never existed anywhere outside the private concert hall of your dreaming consciousness. Every dream you have ever remembered once existed in far greater richness and detail than the fragments that survived the journey into wakefulness. The remnants that reach morning consciousness are traces of experiences that felt complete, vivid, and fully immersive in the moment of their occurrence, like visitors from another dimension. Dreams arrive fully formed in all their intricate detail and depart, leaving only faint impressions behind. The dreams you will never remember were exactly as real and elaborate as those you do, unfolding with the same conviction and sensory richness in the private theater of your sleeping mind. Performances given with full commitment to an audience that will forget them by morning. The darkness behind your closed eyes becomes a screen for an infinite cinema that plays for you alone. Night after night, year after year, decade after decade, your sleeping brain projects experiences that engage every sense and every emotion with absolute completeness. This creative capacity costs nothing, requires no conscious effort, consumes no external resources, and functions with perfect reliability, whether or not you pay it any attention whatsoever. It simply is what brains do when freed from the continuous demands of interpreting and responding to the external world. Dreaming is as natural and inevitable as breathing, as fundamental to your brain as pumping blood is to your heart. Sleep and dreams evolved long before human beings appeared on this planet. Our distant mammalian ancestors dreamed, as did the ancestors of every bird and perhaps every reptile alive today. The dreaming brain is an ancient biological inheritance, shaped by hundreds of millions of years of evolutionary pressure to serve purposes. Scientists are still working to fully identify and understand. When you dream tonight, you participate in something older than humanity itself, older than language, older than the ability to wonder what dreams mean. The capacity to dream was ancient when the first human beings opened their eyes and looked up at stars they did not yet have words to name. The boundary between sleeping and waking consciousness is not a sharp line, but a gradual, extended transition. Awareness dims slowly, rather than switching off like a light. Dreams may begin forming before full sleep arrives, and their emotional residue lingers long after waking has been achieved. We spend our entire lives moving continuously back and forth across this soft, permeable border, neither fully in one state nor the other during the transitions. The experience of drifting off to sleep is itself a kind of journey, a passage through intermediate states of consciousness that blend the characteristics of both worlds in combinations that shift from moment to moment. Dreams illuminate something profound about the fundamental nature of all perception. What you experience as solid, stable reality during your waking hours is also, at its deepest level, a mental model, a construction assembled moment by moment from raw sensory signals by the same neural machinery that builds dreams. Dreaming simply makes this constructive process more visible and obvious, generating complete perceptual experiences without any external input whatsoever to anchor them. In this deeper sense, all conscious experience shares something essential with dreaming. Both waking perception and sleeping dreams are shaped by the brain's extraordinary interpretive and creative powers, differing primarily in their source material rather than their fundamental nature. Some dreams return you to places you have not visited in years or even decades. The sleeping brain preserves detailed spatial memories of locations that waking consciousness has long since forgotten or allowed to fade beyond voluntary recall. In dreams, you may walk again through the rooms of a childhood home that no longer stands, explore the corridors of a school demolished decades ago, or wander through landscapes from holidays taken in another era of your life entirely. Memory preserves far more architectural and spatial detail than you can consciously access during waking hours. Dreams occasionally open these hidden files, granting brief returns to places that exist now only in the vast, silent archive of your sleeping mind. The characters who populate your dreams are created entirely by your own brain, even when they appear to act with complete independence, surprise you with unexpected words, or behave in ways you would never consciously choose. The person who startles you in a dream is a construction of your own neural activity, speaking lines your mind composed and performing actions your brain choreographed. Dreams demonstrate the brain's remarkable capacity to simulate other minds, to imagine perspectives, motivations, and responses beyond your own conscious awareness. You dream alone every night, yet you populate those solitary dreams with an entire cast of characters, each one a facet of the same dreaming mind, each speaking with a voice that is secretly your own. So, could dreams fundamentally change how we understand ourselves? In many ways, they already have. Dreams demonstrate that consciousness is not a single, uniform thing, but a spectrum of states, each with its own distinct character, capabilities, and possibilities. The self that dreams is still recognizably you, experiencing life in its own particular way, contributing to who you become each morning without your awareness or permission. The strangeness of dreams ultimately reveals how strange consciousness itself is. That subjective awareness can exist at all, that physical neurons can produce the felt quality of experience and emotion and beauty, remains among the deepest mysteries in all of science. Dreams are strange because consciousness is strange. They remind us, gently, how extraordinary it is to experience anything at all. And so our quiet journey through the dreaming mind draws gently toward its close. We have wandered from the hidden chemistry of REM sleep to the universal themes that visit every sleeping mind around the world, discovering along the way that dreams are not random noise, but carefully structured experiences emerging from your remarkable, endlessly creative brain. From the emotional theater of the amygdala painting feelings onto nighttime visions, to the prefrontal cortex stepping gracefully aside to allow imagination its fullest range, we have glimpsed how dreaming is both an ancient inheritance and a nightly renewal, something given to every sleeping creature as naturally as breath. Dreams remind us that consciousness is vast and varied, that much of what our minds accomplish happens in silence, in sleep, in spaces we can never directly observe. They teach us that we are creative beings of extraordinary capacity, generating entire worlds from nothing while we rest. Without dreams, something essential to our nature would be absent. By pausing to notice their quiet presence, we glimpse the extraordinary hidden within the most ordinary act of closing our eyes. And now, in these final moments, take the deepest breath you can manage, as deep as your lungs will allow. Think about the unity of your mind. Every thought, every memory, every emotion existing together within the same small space behind your forehead. You are not separate parts assembled loosely together. You are a whole being, moving between states of awareness as naturally as the tide moves between shore and sea. Think about consciousness itself, yours, and everyone listening in the quiet darkness, and every awareness everywhere, all of it perhaps connected in ways that science has not yet found the instruments to measure. You are not alone in the vast universe of dreaming minds. Let your entire being dissolve into the ocean of rest, into the space that exists before thought begins, into the darkness that holds everything and asks for nothing. Prepare for deep sleep. No boundaries remain. only peace. If this quiet exploration of dreams brought you comfort tonight, whisper it forward to someone who might be lying awake somewhere. It may bring one more wandering consciousness a moment of peace, one sleepy soul at a time. But there is nothing you need to do now. Nothing at all. You have traveled far tonight, further than most journeys take you while your body remains perfectly still. You can allow these thoughts about dreaming to fade now, like the dreams themselves fade each morning, leaving behind only the quietest calm. Let your breathing deepen. Let your body grow heavier, as though gravity itself is gently, lovingly holding you in place. If sleep comes, let it carry you like a slow river, smoothly and inevitably, into a realm where time and weight and worry no longer apply. If your eyes are still open, another journey awaits you whenever you are ready. But if they are closed, stay there. Stay in the warm darkness that feels safe and familiar. Tomorrow, your dreams will still be waiting. The sleeping mind will still weave its nightly creations with the same care and purpose it has always shown. But tonight belongs to stillness. Rest well, gentle dreamer. The worlds your sleeping brain builds tonight are gifts from the deepest, most creative parts of who you are. Where science meets sleep, wonder never ends. Good night.